Hey y'all. Okay, let's do more problems. Okay, so we stopped on a 13. We're gonna do 14 now. Problem 14 says to I'm not gonna be able to get all of it. Y'all, that right there, that's gonna be the product rule and the quotient rule and the what we use whenever we have a exponent um, within these logarithms. Problem 14 says to use properties of logarithms to expand the logarithmic expression. There's not an equal sign, y'all, so it's an expression as much as possible. So it's log base 6 of the square root of 5x. Okay, so this is problem 14, and it is log base 6 of the square root of 5x. So the first thing I want to do is actually change that square root into something other than a square root. Thinking about my exponent rules, I know that if I have something raised to a fractional power, I can actually take the root where my denominator is the root. And so since this is in a square root form, what I can do is actually make it a fractional exponent. And so what I would do, I'm trying to look at how I wrote it. Okay. And so what I would do is actually do log base 6 of, and now I have 5x to the 1/2 power because the square root and the 1/2 power, those are equivalent. Okay. And so now what I'm going to do is I'm just going to notice that since I have that exponent, what can happen is it can actually come out front as a constant. Sorry. So I've got, I'm trying to think, should I write it in front? Should I write it in the back? I'm going to go and write it all the way in the front here. Because there's multiple things going on inside of here, I'm going to put it inside of some brackets. I've got log base 6 of, now it's 5x. And then what I notice is since the 5 and the x are multiplying each other, that would be the product rule. What I can do is actually take each individual factor, like the 5 and the x, and still using the same log base 6. I can write it as a sum. So you take your 5, and then we're going to add that to log base 6 of x. And that was because they were multiplying each other. What I'm doing is expanding, right? And then I need to actually go ahead and distribute this 1/2 in. And that's going to be positive 1/2 log base 6 of x. And so that actually ends up being my answer. I kind of wanted to do that in red. So that will be my answer right there. And let's look at problem 15. Problem 15 is log base 4, and then in parentheses, I have something in a fractional form. It's x plus 6 divided by x to the 7th power. And so what I would notice here is first that because these are being divided, that means that I could write it as a difference of the two of them. And so I'm just going to kind of expand this a little bit, and then I need to look to see, is there anything else that I need to do? I would take log base 4 of my numerator, which is x plus 6, and I would subtract from that because they're dividing log base 4 of x to the 7th. And then I need to notice that since I have an exponent here, it's actually going to come out front and become a coefficient. So we'll get negative 7 log base 4 of x. Okay, so that's how you do those problems. We've got one more in this problem, like in these directions. That's going to be base b, xy to the ninth, z to the fourth. So log base b of x, y to the ninth divided by z to the fourth. First thing I notice is since it's division, I'm going to write them as a difference. You are going to make sure that they each get your log in whatever base you're in. Put your numerator first, and then do your denominator. And then looking at this, I have exponents. So those exponents will actually become coefficients. But what I notice that I need to do before that is that first log, I actually have x times y to the ninth power. Because those are multiplying each other, it's actually going to be expanded as a sum. Let me get this, okay. So what we have is log base b of x, and we're going to add to that log base b of y to the ninth, then subtract from that log base b of z to the fourth. And then here is where I can go ahead and bring those exponents up front as coefficients. So my final answer ends up being log base b of x plus 9 log base b of y, a negative 4 log base b of z. Okay, so for problems 17, 18, and 19, we're actually going to condense. I'm going to go ahead and cancel this video, or you know what I mean, like stop it, and then I'll come back and do the problems where we condense. All three of those problems we just now finished are all expansion. And so if y'all have any questions about these problems, make sure y'all ask, okay? Thanks. Bye, y'all.